our first Berman Institute seminar of 2014. So welcome. It's my pleasure to introduce our speaker today, who is Eric Juengst, you see from the slide. I think I get the honor maybe because we go back among the furthest, that's right. Eric and I were almost graduate school classmates. He was a little bit ahead of me. And I will say, yours was the first dissertation defense that I ever attended. And so it was very successful and easy, and I think all of us who were there felt freed of anxiety having watched you go through it. So a role model. You probably have seen his bio, but I'll just do a very quick, abbreviated version of that. So you heard that Eric did his PhD at Georgetown in philosophy. He went from there to be the first director of the ELSI program, the Ethical, Legal, and Social Implications program at the National Human Genome Research Institute, a very influential area in policy, ethics, law, social implications, and genetics. He also has taught at UC San Francisco, Penn State, Case Western Reserve for many years, and most recently has been the director of the Bioethics Center at University of North Carolina at Chapel Hill since 2010. Among the things that make him really an important person in our world is that he's been very involved in the Centers of Excellence in ELSI research and genetics, both from his time at Case and now in his current position at the University of North Carolina. So we're really pleased to have him here. He's going to talk about a very provocative issue, which relates to, as you see, opportunistic genetic screening, and it goes to the current policy debate from the American College of Medical Genetics related to genetics testing and screening, which he'll talk about today. So please join me in welcoming Eric Juengst.
Thanks, Jeff. It's great to be back. It's my first time back visiting the Berman Institute since you've moved into your wonderful new building, and I'm so impressed. That's really first class. I want one. Well, some of us have been laboring in the fields of ethical and social issues in genetics and genomics for a long time now, since the 90s for me. And we've always taken a good bit of care with how genetic tests are offered to the public, how they're offered in clinical settings. And we've even been accused of being genetic exceptionalists, putting too much care and protection around the provision of genetic information to people who, in this day and age, after all, are savvy about their genes and are quite equipped to deal with it themselves. So goes the argument. But suddenly, the last spring of 2013, the ethics and genetics community woke up to a whole new world. Suddenly, quite apart from being integrated into routine practice, genetic testing, genomic sequencing, was being treated as simply something one does in the clinical setting on the fly. As long as you're examining a patient, why not sequence their genome? Well, that's a caricature. But that's the setup for this talk. Are we ready to have genomic sequencing of patients done opportunistically in the clinical setting? As long as you're here for a physical, let's run your genome and see what pops up. There might be things we can get out ahead of and fix. I want to tell you the story of how we got to this strange place. The place which I'll call by its acronym, the land of OGS, Opportunistic Genomic Screening. I want to tell you a little bit about the debate that's gone on around it, in particular to look at some of the traditions in medical ethics about how we disclose information to patients when it's appropriate to unilaterally go looking for trouble, unilaterally go looking for something and telling patients about it without their prior knowledge or consent or understanding. And then to see if any of those traditions are helpful in this context. But then to tell you a little bit about what's going on in Chapel Hill with our project in this domain, where we're wondering about what the role for opting out is for patients in these settings. Is it as simple as clicking your heels and saying there's no place like home, or more complicated? So a little tour through the land of Oggs. How did we land here? What got us here? Well, remember the story of Dorothy. The first was a tectonic shift, the genetic paradigm shift, taking us from Victor McCusick's collection of Mendelian traits, OMIM, to the much larger world, a much larger set of single nucleotide polymorphisms, thanks to the Human Genome Project and our abilities to identify very discreetly and accurately those tiny changes in the genome. This was heralded presciently by Patricia Baird, a Canadian geneticist. In 1990, the dawn of the Human Genome Project, she really says very clearly what the agenda is. We need to see our own genetic individuality as the potential origin of disease. Now, we've been fighting off external toxins, poisons, and pathogens for a long time. Now we need to look inward. We're all different. We're all genetically unique, which means our risk for disease is different from one another. Progress depends on realizing this. So she was foreseeing a paradigm shift in healthcare, and that's certainly the ethos, the ideology, the energy that fed the Genome Project and has fed genomic medicine ever since. Whoops. One of the things that we were thinking about when that paradigm shift was happening in the Genome Project in the 90s was what happens when you take Victor's collection and tell the public, now we have discovered 30,000 more like them. His collection of Mendelian traits were the simplest stories to tell in genetics, right? Because we could see them being passed down through families, these mutations. And so they included the most deterministic stories we had to tell. If your family has a history of Huntington's disease, you have a 50% risk of inheriting it. So the image of genetic testing, of looking for genes after the Genome Project, was a very deterministic one, almost magical. This is, one of the most common icons of the new wave of genetic tests is a crystal ball. Well, think about it. That's attributing occult powers to genomic testing, and attributing it the ability to tell you, like the fortune teller, what your experience of your genetic future is going to be. Spent a lot of time at NIH and with the LC program trying to diffuse this over-determinism and trying to sell the idea that actually, as a predictive tool, genetic screening is going to be much more like the weather forecast. Also a predictive tool, but like genetic screening, it's a probabilistic prediction. It's going to vary with local environments. It doesn't try to tell you how you're going to experience the weather. And it's relatively humble. It's understandable by the public. Public also knows to take it with a grain of salt, right? I've never really been able to sell this image as the poster image for genomics. It has something to do with having to wear those blazers. genome scientists aren't thrilled about it. But by the 2000s, with the completion of the Genome Project, we're ready to move on from the genetic paradigm shift to what Francis Collins calls the Genomic Revolution, another earth-shaking development, from single nucleotide polymorphisms, single tests, to sweeping the whole genome, the genome-wide association studies, in order to do genome-wide scans in order to tailor your medicines directly to your unique overall genetic constitution. The arrival of personalized genomic medicine, as Francis heralds in his book, DNA and the Revolution in Personalized Medicine. Echoing Patricia Baird, he says, we're on the leading edge of a true revolution, transform one-size-fits-all approach, much more powerful strategy that considers each individual as unique. You've heard this rhetoric many times already in any talk about personalized medicine and pharmacogenomics. Interestingly, and one of the projects we've been doing is to look at the case for personalized medicine as it's made by its proponents and what the virtues of this new paradigmatic revolutionary approach to medicine are supposed to be. There's a mantra in the literature that spells out 4 virtues, and these are them. Leroy Hood, in his brand of personalized medicine, even goes so far as to suggest rebranding the field P4 medicine, because these are the 4 Ps that are the promises. It's going to be more predictive, more preventive, more personalized, and more participatory. A lot of rhetoric about how genomic medicine will bring the patient in to take control of their health care more actively and empower them to make important health decisions. Well, I put that one in red because I want to come back to it as we move along. It's an interesting inclusion in that list. Okay, in addition then, finally, we've got in the last few years what I'm calling the sequencing sea change, just to continue the tectonic metaphor, from doing genome-wide association studies and genetic scanning to actual genome sequencing in patients. Whole genome sequencing or whole exome sequencing, sequencing all the parts of the genome that code for proteins. With that comes the advent of, well, the reduction of cost in sequencing technology, which allows us to begin to think about taking sequencing machines into the clinical setting and running DNA decoding, genetic sequencing for patients. So, grand challenge of the last phase of the Human Genome Project to get down to the $1,000 genome. Now we're at least to the $200 genome, and prices are falling fast. So it's a realistic possibility. The result of all these tectonic shifts is the data tornado, the data tsunami, which we hear so much about. Because once you start sequencing whole genomes, you get a lot of information, right? Those 3 billion base pairs. And a lot of it is hard to know what to do with because we don't understand most of it. So lots of information to try to translate for patients that we weren't necessarily looking for, that we didn't expect, that's incidental to the reason we went into the sequencing exercise in the first place. And Zach Kohani at Harvard wrote a nice article a few years ago talking about this as the incidentalome, which he saw was the threat to genomic medicine, because once we start sequencing whole genomes, across the general population were likely to yield unexpected incidental findings for nearly everyone. A lot of information in your genome. And it piles on to all the other forms of genetic testing that have preceded it. So you get this cascade of increasing amounts of information that we need to be able to filter through and translate to patients. Thus the tornado taking us in the direction of OGS. The incidentalome has become the wicked witch of OGS because that's what makes it scary. What are we going to do with all this incidental information? Should we give it all back to patients on a CD and let them deal with it? Are we going to be able to filter it adequately for clinical purposes? And also, what about these flying monkeys, the minions of the incidentalome, the direct-to-consumer companies that are already winging their way into people's homes with this information? They have all have names that suggest very deterministically that this is something you should know about and use for your own life planning. Know me, decode me, 23andMe. They're out there. Cover the windows. Because there's a lot of concern about what a patient's supposed to do with a readout from one of these companies, even though they try to provide some interpretive information along with the report. And more importantly, what's going to happen when the patient brings it into their physician's office. So, step 5 in our trip to OGS, a wave of calls for somebody put some cold water on this witch of the incidentalome. We've got to step back a minute and think, who should be the gatekeepers of this complex genomic information? Well, we should be the gatekeepers, say the docs. We're the clinicians. We're the appropriate parties. We should, it's all well and good to sell genomic testing to the public for recreational purposes, but when it begins to make healthcare claims, you should be doing this through your doctor's office. So articles like this one, Jim Evans, one of my colleagues at Chapel Hill, saying that the role of professional judgment in interpreting these tests is crucial. And regulation should be set up to ensure that genetic information just isn't delivered to the public cold. Also, in the calls for cold water, or at least some lukewarm evidence, the NIH responded by saying, right, it is kind of scary having this data tornado approaching, being propelled by direct-to-consumer concerns. So we should study this and figure out how to do it right, how to do clinical sequencing right. So they set up a consortium of studies, the Clinical Sequencing Exploratory Research Consortium, and its sister group, the Return of Results Consortium, to do clinical empirical studies on how to deliver whole genome information to patients. The program is intended to support both the methods needed to integrate sequencing into the clinic and the ethical and psychosocial research, interestingly enough, required to responsibly apply personal genome sequence data to medical care. And of course, this is a critical place in the genome community's overall strategy for translating genomic information to public benefit, because without being able to do this, it's kind of hard to see what sort of impact genomics could have in a major way. As a result, we've got these waves of clinical trials, I guess you could call them, clinical studies. They're not RCTs, but a wave of studies of how to use sequencing to solve diagnostic mysteries in the clinical setting. We've got one of those grants that goes under the acronym of NC Genes, and they're doing whole exome sequences of selected patients in a number of services at UNC Hospital, and trying to figure out systems for dealing with the incidentalome, first of all, never mind giving back the results, the answers to the mysteries they came looking for, but dealing with the other information that they're finding and studying the impact on patients and their families. Well, of course, there are other places besides the clinical setting where we do genetic screening, like in our newborn screening programs, and that rose to the surface quickly as another obvious opportunity for sequencing technology. Why not do genomic sequencing as part of a newborn screening program while we're at it? Ooh, incidentalome. What are we going to do about that? Well, let's do some studies pilot studies of ways to use sequencing technology responsibly in the newborn screening context. There's another consortium devoted to those. We have one of those grants. And suddenly, screening seems to be happening all around us. Most recently, building on this notion that maybe genome sequencing has a place in public health, newborn screening being the model for a public health program that might use it, my colleagues had the idea, why not preventive genomic screening for adults? Nice article, or at least a prominent article by Jim Evans and a couple of other my colleagues. They screen newborns, don't they? That was the title. If we screen newborns on the rationale that where we can identify severe diseases that we can intervene to prevent, we should. Why aren't we doing that for adults? Where we can identify severe, predictable, late onset diseases which we can prevent, why not do that as a routine public health matter too? So, as part of our Center of Excellence in LC research at UNC, we've launched a project to ask that question: what are the merits of bringing genome sequencing into the doctor's office as another health screening that you might do along with your cholesterol screening and your mammogram, more or less for public health purposes? North Carolina Gene Screen joins the list. Meanwhile, the City Guard speaks up. The City Guard being the American College of Medical Genetics, who says, right, there's a lot of sequencing going on, a lot of incidental findings coming out, and when we've got these incidental findings in our hands, it seems immoral to sit on them. If we've got a whole genome, we should take the time to look in the corners where we know live severe preventable risks, test for them, and report those back to patients. Just like if I was doing an X-ray, I wouldn't turn a blind eye to strange spots that I saw, even if that's not what I was looking for. No, I would look into those and report the results back to the patient. It's incidentaloma, maybe, but it's part of my duty to protect the patient from harm to go look for and report those kinds of findings. So this committee came up with a list of 57 genes that they said should be sequenced whenever you've got the sequencing machine warmed up for a patient. Opportunistically, whatever you're doing, whether you're trying to solve a diagnostic mystery or trying to look for newborn metabolic disorders to intervene on, You ought to sequence these 57 regardless of patient age, because these are things that are clinically significant mutations which we could do something about and possibly save people's lives. Now this report was addressed to laboratories, saying that the labs doing the sequencing should look for all these and include them in their report back to physicians. But there was also the assumption that, yeah, and physicians should report those back to patients, even though they left that a little wobbly to say, of course, physicians have to use their judgment, but we're suggesting that these are important things to report back. And now the commercial direct-to-physician suppliers of whole exome sequencing are happy to get on board. For samples arriving after May 1st, GeneDx will be following the recently released American College guidelines and sequencing these 57 mutations for you. What's their case for their professional obligation to go looking for trouble in this context? Well, they say, we've got the general duty to rescue when we have the power to do so as physicians. In this case, sequencing technology has given us that power. We can see these troubles ahead. We have, and when we see them, we have a general duty of transparency. Part of our doctor-patient relationship is not to hold back important clinical information that we stumble on just because it wasn't part of what we were originally looking for. And apart from those general ethical obligations that might apply to anyone, as doctors we have this special fiduciary relationship to prevent harm to their patients. So Jim, again, Jim is peppered all over this literature. Medicine is, at least to some extent, an inherently paternalistic endeavor, simply because of an inevitable asymmetry in knowledge, because those who practice medicine pledge to avoid causing harm. Interesting. So what happened to that patient empowering and participation virtue in the 4P medicine? Maybe in the end, if we're going to need expert gatekeepers to interpret this and actually tell us what we need to know, maybe we need to back off that, hitting that button so hard. And part of that, the sense was that people got confused when we called this personalized medicine, because that suggested they were going to have some say in what was going on. So let's back off that and let's rebrand it precision medicine. Precision medicine. So the IOM report comes out and says, yeah, personalized medicine, that's kind of awkward. Precision medicine is what we're doing, because it has nothing to do with the patient's preferences. It has to do with precisely calibrating their risks in molecular terms. And now precision medicine is taken off as a term of art around the country, interestingly. Okay, so if we take Jim's conclusion that medicine has an obligation to prevent harm, and that might lead it to be paternalistic in some cases, yes, we've lived with that for a long time in medical ethics. It would also apply to the obligation to prevent harm from bleeding out. In a Jehovah's Witness case, doctor would have just as strong an obligation to be paternalistic and prevent harm, but we've kind of made the social decision that patients ought to have the leeway, well, the right, to make important healthcare decisions about themselves, even if they're life-threatening decisions. So there must be more going on than just simply this baseline obligation to prevent harm. What can we learn from our traditions? We have been scouring the literature of 10 or so traditions. Some of them don't offer too much to this particular debate, like the old therapeutic privilege, except for the fact that it's kind of the mirror image of what's going on now. Therapeutic privilege was your professional right to keep quiet about scary diagnostic results and not tell patients about their state of affairs if you thought the news was going to hurt them or upset them. That's the doctrine that's seen its day come and go with the arrival of a more patient-centered ethic in medicine, with the arrival of notions that actually patients have a right to know their diagnoses, their prognoses, the decisions that are being contemplated, and that shared decision-making, in some ideal version of that phrase, is what should be going on in the clinical encounter. Decision-making about treatment, for sure. Decision-making about which diagnostic tests to do, well, presumably yes, but that's a question to think about. Certainly in genetic counseling in the past, if you would look at the genetic tradition, the tradition has been very strong on protecting families and patients' rights not to know risks they would care not to know. And even though that's a controversial phrasing from a philosophical perspective, what does it mean to have a right to ignorance, right not to know? That seems counterintuitive. How can you give an informed consent to not get information? Nevertheless, in practice, it's a palpable value. And the duty to warn, to breach confidentiality in the genetics setting, is very carefully parsed. Yes, there are times when you could unilaterally disclose some information over the patient's wishes to other family members, but only if and only if certain criteria apply. And this if and only if algorithm, this iffy algorithm, is the common theme through all the traditions of disclosure that we've been looking at. Basically, in breaching confidentiality, mandatory reporting to state agencies, you name it, it's something like this. Unilateral disclosure of information, that is, regardless of the patient's preferences, is justifiable only when you have a certain level of certainty. That is, the information you have is very predictive of a known harm to come, certain level of actionability, you can do something to prevent the harm, and a certain level of urgency. It's actually a severe harm and it's actually imminent. These get spelled out and defined in different ways, but I'm sure that it's recognizable to you because it's the clinical language that we use in genetic testing. And one of the things that my colleagues in the NC Genes project have been trying to do is to provide a kind of semi-quantitative system for binning mutations against this kind of algorithm. So if I won't bother to go through my ersatz math here, but these are the breakdowns of those three words. And if you can't have an arbitrary scale and say, let's have a 5-point scale of how strongly we're sure that something is analytically valid, clinically valid, has utility, etc. And we assign points to genes across this scale. We can come up with numbers that show you generally how warranted it is to test for and disclose this kind of gene. ApoE4 mutation, only comes up to a 12 out of 25, so you might say, yeah, that's probably not one a remote risk for Alzheimer's disease that you would want to go out and opportunistically screen for. I'll move through these other precedents quickly because they're basically corroboratory. They all, in the end, we think, rely on this iffy algorithm, one kind of form or another. A return of research results should let the volunteer decide what results to announce. But if and only if it's really urgent and really actionable, etc., maybe you should go ahead and tell them unilaterally. Duty to recontact individual volunteers. Yes, you should seek out old subjects and warn them of new information, if and only if. Incidental findings, similarly, and the President's Commission's new report on incidental findings takes this approach as well. Newborn genetic screening, how do we add a new test to the newborn genetic screening panel? Well, if and only if. And opportunistic screening in other settings, the X-ray, incidentalomas, or other findings of incidental sorts on clinical tests. So, the question is how many of these 57 genes, how many of the incidental findings that NC Genes is spinning out would meet such a semi-quantitative assessment for whether or not it's important enough to disclose. To hear the guardians of the city, to hear the ACMG authors talk, we're in the same state as our local severe weather warnings are. One place where we don't protest about unilateral warnings, unilateral disclosures of impending risk, is when there's a tornado barreling down on you. There, at least at our place, there are big loudspeakers on the campus that blare out, "Tornado sighted, take cover now, take cover now," and everybody gets all unnerved. Because those are real code red warnings, right? So is that the situation we're in with these opportunistic genomic tests? Or is the analogy more like, well, a low pressure area has been detected that might become a hurricane, that might flood your street and trap you in your car, so either keep watching the Weather Channel or sell your house and move out of state now. That's I think, closer to what most of these genomic weather forecasts are going to provide to people. And whether that merits the loudspeaker is the heart of the question. Here's the Wizard of Oz, Jim Evans, because he came up with a very interesting idea for this last project, the NC Gene project, about preventive genomic screening in adults. So let's go behind the curtain of the wizard and talk about that for a minute. He said, you know, we don't have to get into this awkward position that the whole genome sequencing projects have gotten into if we don't sequence the whole genome. Why would you want to march through all that DNA unless you really had to for some diagnostic mystery? If you already know the 57, or let's be more conservative, dozen genes that we're most sure pass the iffy test, that we're most sure predict severe harm that we can effectively prevent, why not just sequence those loci, sequence those regions of the genome? And then we won't get incidental findings, at least of the same order of magnitude, because we'll only get the results about those mutations, the ones we look for. Oh, good. That's great. Then we won't be burdened with all this information we feel like we have an obligation to share without, regardless of the patient's preferences, and we can avoid that paternalism problem because we'll ask patients' consent in advance to whether or not they would like these particular loci sequenced, and we won't be trapped by the incident alone. We'll develop a process for vetting these mutations to make sure we're having the top of the cream of the crop, only the most urgent. And that's what a lot of the work on this project is doing, trying to develop this system for vetting genes, for deciding what to test, who to test, and how. That's the empirical side of the project. But it's not already without challenges 3 months in, because here's an issue that's come up, and here's me speaking out of school without permission from my colleagues there. But I think it's instructive. Should we offer this selected panel of loci to patients for preventive purposes as a panel, as a block, and say, right, you get the whole panel or you get nothing? Or should we offer it to them as a menu and say, well, you can choose, if you want to, which of these mutations you're most interested in, and I'll sit down and explain to you. Because when you do the semi-quantitative exercise, you end up with an incredibly polyglot set of genes. They've all passed the IFFI algorithm, but they're wildly different. You know, sudden death from cardiomyopathy, Lynch syndrome, colon cancer, hemochromatosis, iron overload disease. Patients might have views on which of those risks they're more concerned about than others, and might want to be able to make a choice. The default view is that, well, sure, they should be able to opt in or opt out or choose. There's no place like home if home is where patient autonomy is recognized and protected. This would be the usual moral framework. Plus, if you let people pick and choose, you're not going to be left back in the incident alone situation with a set of information that you got because you did the whole panel and you know the patient isn't really all that interested in, but you feel an obligation to tell them. Nevertheless, our colleagues are resistant. The panel makes much more sense to them. Why? Well, there's complications. For one is, we're just doing a pilot study. If we let people pick and choose, we're never going to have the numbers in each square of our grid to be able to say anything. So this is a research design consideration. And you might have to say, all right, for the purpose of this trial, we'll do the panel rather than the menu. But what about our recommendations to the field afterwards? If we're going to suggest that this would be a good addition to the clinician's preventative toolbox? Well, yeah, but there are practical limitations. Much more complicated technically to let people to modularize the panel. Much more expensive. And who's going to do all that genetic counseling that's going to have to go into explaining these 12, even if we only do 12, these 12 different conditions and 12 different sets of mutations to each patient? No. Let's just do it like we do other sorts of, preventive screening panels. Say, oh, wouldn't you like the genome health screen? And besides, we can't let patients pick and choose because we have obligations and they have obligations to their family members. This is an interesting argument that's come up. This is as much about screening their family as it is about screening them. And so that's the point of having the panel, so that we can identify families in which some of these mutations might be inherited, so that we can go out and work with them. It's a public health goal. Contact tracing, if you will. And that leads them to say, and anyway, do we let parents pick and choose across the newborn panel? Oh, we don't. It's a public health intervention, and that's what we're doing. Yes, we deny them a little autonomy in that score, but it's on the basis of our belief that it's benefiting the community, that it's the greater good to the community, which is a perfectly legitimate public health rationale for compromising a little bit people's personal choices. So why don't we just look at this in the same way and say, this is a public health intervention, and therefore you get the panel or nothing. That's where we are, in the middle of this interesting debate. I think it comes down to this interesting question about whether this intervention we're proposing to experiment with in doctors' offices is in fact a public health screening tool, or whether it's just part of a personal preventive care plan that a doctor is going to offer a patient, which puts it much more back in the traditional clinical model. Beyond that, there are lots of other interesting ponderables about this that we're hoping to be able to sort out with the help of the rest of you in our community over time. But that's the real story I wanted to tell today. So, on behalf of my colleagues who didn't know what I was going to say at the Center for Genomics and Society, thanks very much.
Perfect, thanks. So we have just shy of 15 minutes. You want to just point or call on them if you know their names?
Okay, Deborah?
One of the tensions that I think is really interesting in these conversations is the one between this information is so powerful, people are not going to be able to handle it adequately, and that it's going to be like a weather report, and all the data we have suggests that people have a little spike in anxiety and then go back to baseline. And it's sort of trying to be both things, sort of ho-hum, and it's like a weather report, and yeah, you look at it and you take your umbrella,
Right.
but versus it's this incredibly sensitive, difficult, unusual, unique information that we have to treat with kid gloves.
That is an interesting tension. And, I think over time, as we all get used to it, that genetic exceptionalism that gave that powerful psychosocial potency to the information is dwindling and fraying. And so it will be more like a weather report. The question then for this, for our purposes is, does that mean that it should be more voluntary to go seek out? It's perfect. Nobody prescribes an astrologist to me. You really should go get your horoscope done for your health. No, because we think that's probably not so predictive. So it's perfectly voluntary and elective. Maybe that's the way we're going to go. That's the way it would go. Or you could say, it's no big deal, so why not let the physician do it opportunistically?
Can I follow up?
Yeah.
Are there any instances that you found where a particular class of information has been parsed such that some of the information is treated in the more special way, whereas the rest of the information is sort of more casually available? So could we say that for those 12, if that's our number we're going to pick, you do have to go through medical personnel, but for everything else, 23andMe, go for it.
And take your own risks.
Right, buyer beware.
Yeah. I suppose that's how it could fall out. In terms of examples along those lines, I wasn't thinking about the direct-to-consumer market, but we did have the practice for a while of sequestering psychiatric diagnoses within the medical record and adding special protections to sensitive information like that. There are probably stories from the HIV crisis along those same lines.
So that wasn't an access issue in terms of access to the information.
No, that's right. Yeah. Interesting. Think about that. Yeah.
So I'm not certain how this is different, say that it's newer from other sort of medical interventions. I go to a medical doctor and he orders blood tests. And I don't look at a menu and I don't interview him on what blood tests he's tested for. Tell him, no, I'm not interested in tests about my kidney function. I'm only interested in the other tests. He's my medical doctor. I trust him.
Right.
He tells me this is important to my health. I go out and I get the blood tests. Why is this panel of genetic things, which have clinically important medical functions, avoiding the incidental of, as you say,
Right.
different in kind from that medical treatment?
And that's what Jim asks. And, maybe it's the lingering legacy of this genetic exceptionalism that leads folk to say, when it comes to learning your downstream predictive genomic risks, you ought to have more control over that than when it comes to learning about your kidney function. Is that rational? I'm not sure, but that's the argument that we're trying to attack.
Just to add on to that, just to move it away from self-regarding health conditions.
Yeah.
When there's a sample that's been drawn for, let's say I'm tracking somebody's thyroid condition, I need to know their TSH, and I have a serum that's ordered, and I have a sample that would lend itself to other forms of testing. Well, leaving aside other, again, self-regarding health issues, it's certainly possible to run a battery of infectious disease screening tests on that sample once I have the serum. Those are no longer self-regarding. This is classically public health. Right? This
Right.
person's a potential vector of HIV, Hep B, Hep C, any number of other infections. And we could do that, but certainly the LC community-run ID issues has not made that something that we do in a way that the clinician and the patient can't opt out of, or don't even consider. It's just done as a matter of course by the laboratory. Is that,
It's a good example. It's a good example, and I can point to a difference there, and that is clearly done on a public health rationale.
but we don't do it.
But you're saying we don't do it.
We don't do it.
So that's even more interesting. There's a public health rationale, but we've decided to bow to the physician-patient relationship and let them decide. So why do you think that is?
I mean, again, it seems to come back to a certain deference to the, is there a pre-test expectation that there is some chance of these diseases? Is this a concern based on, it's not, it seems to defer to clinician judgment
Right.
about whether that test should or should not be ordered.
That's part of the problem here, is that part of the rationale for doing this screening is the assumption that there is no pre-test reasoning to do this testing. Because if you had any sort of symptomatic or clinical reason to investigate these 12 genes, you would do it one by one. If you've got a family history of colon cancer, well, maybe we should look for the Lynch mutation. So it's only in families for whom this would be a surprise that it makes sense to do these.
But we know that risk categories and symptoms are only a subset of the people who have these infections. So we
Right.
know we're missing people by not simply pan-testing. And yet, maybe ID got it wrong. I guess that's another problem.
Yeah.
I don't want to question that. Maybe ID got it wrong.
Maybe. But it would be interesting to try to ferret out the reasoning that went into that. In the back?
So I know in prenatal settings, we are now offering a panel of about 100 of some recessive genetic conditions to every patient comes into our clinic. From a public health perspective, all of the 100 conditions have mild to severe clinical consequences, so that's why we offer it now. But from the patient perspective, they have the option to only test for about 12 conditions or only 2 conditions, or they can also choose to test the 100 panel. So I do agree the healthcare providers should be paper for these kind of genetic conditions, but I do think the patient do play an important role in participating in the process. So I think even if have a massive screening as a public health tool, but I think the patient, it can still be personal
Yeah, and of course, in the reproductive genetic testing setting, we've even got the extra issue that the only preventive measures are personal reproductive decisions, which layers and gives another reason to leave it in the patient's hands, in the parents' hands, and protect their autonomy more. So it's interesting, if they get to pick from that menu of 100, does that mean that they're educated about all 100 and counsel?
No, we just broadly spread. And also, no matter how many diseases you choose, the cost you pay will no more than $99. So it doesn't matter, the cost will not change no matter how many patients you choose. So
Oh,
it's
better
totally-
deal to get them all. All right. Yeah.
I was curious about your opinion for the recent FDA action against 23andMe. I think their warning letter is something to the effect that they don't provide provisions for dealing with the skin stone type of thing. There might be more
Yeah.
information. I'm not completely aware.
Well,
Is that a bump in the road? Is it a new direction? What happens next?
we'll see whether it's just a bump in the road, but it's kind of, people have been waiting for the FDA to say something like that for a while, because it's been looking like practice of medicine without a license. Yeah, Gail?
So I'm interested in this criterion of actionability, and what the nature of the action is, and what the efficacy of the action is, and the
Okay.
degree to which those are considered in the assessment of actionability. So with newborn screening, for example, the whole PKU justification was that there was a very effective
Simple.
intervention without which there would be catastrophic consequences. That's very, very different from what the evidence points to about the efficacy of behavioral interventions, for example.
Right.
That being told, that you should not smoke or something around someone who has an alpha-1 antitrypsin deficiency is just not as effective an intervention. So how actionable and how effective does the action have to be in determining this?
It's gotten controverted even in our process, interestingly enough, for reasons you would immediately understand, which is that they wanted to say, well, what's the efficacy, the clinical utility? And then they had to decide, do we mean the efficacy of once you find this risk factor, the proximal preventive screening that we'll do? Or do we mean the efficacy of the ultimate intervention, the ultimate surgery we would have to do if in fact you did get breast cancer, you did get colon cancer, because those are quite different. So now they've started trying to tease apart and rank separately the actionability of the proximal intervention and the distal intervention. But then that's supposed to be balanced against a vague criterion they call acceptability, which is basically how burdensome is the preventive intervention. Are we talking about a special diet? Are we talking about prophylactic surgery and the removal of major body parts? Because that's also a variable that seems important to try to capture. And acceptable or burdensome from whose point of view? So we're working with a community advisory board that is most interested in those definitions, and ranges, from the cancer survivor who says, well, my point of view, pretty much everything's acceptable if the alternative is cancer, and others who say, no, quality of life is really more important. In fact, I'd rather have that gene where you suddenly drop dead than the gene that's going to put me suffering with cancer for the rest of my life.
I think we have to end there, unfortunately. Lots of food for thought. Thank you.
Okay.